Viewers, welcome to add-on. In this question, we are asked to minimize the following expression using K-map, and this is a four variable K-map because there are four variables here: P, Q, R, and S, and these are the main terms, and these are the don't care terms. So the term which is expressed by the summation of M, these are the main terms, and the terms which are expressed by D, these are called don't care terms. Okay, so at first we need to draw the K map. So as it is a four variable K map, there are four variables P, Q, R, and S. So the K map will be the size of 4 into 4. Okay, so there will be four columns and four rows, right? So at first let us draw the K map. So the K map will be 4 into 4 K map. There will be four rows. This is the first row, this is the second row, this is the third row, and this is the fourth row. And there will be also four columns: first column, second column, third column, and fourth column, right? And the variable which are given to us are P, Q, R, and S, right? And now we need to represent each of the cell in the K map by gray code, right? We need to represent each of the cell by gray code. Now how do we write those gray code? Okay, so for PQ, this PQ is just representing the row number, right? And as we can see, this PQ, this is a 2-bit variable because P we can represent it by either 0 or 1, and Q we can represent it either by 0 or 1. But if we combine these two together, PQ, we can represent it by 0 0 0 1 1 0 1 1, right, in binary. So we can represent that there are total of four combinations, so we can easily represent four rows with it. And similarly for RS, R is also either 0 or 1, and S is also either 0 or 1. So we can also represent RS in this manner. So for RS we are also getting four combinations, so we can easily use RS to represent four columns. Okay, so the main question arises, how do we use a gray code for this marking of cells? So we need to know the conversion of binary code to gray code. Now what is the conversion of binary to gray? So as I have said earlier, these are the four possible combinations: 0 0 0 1 1 0 and 1 1. So if we find the equivalent gray code of this binary number, this gray code will be used for the marking of these cells. So we need to just find the gray code of 0 0 0 1 1 0 and 1 1. So let us start with the conversion. So the rule of gray code conversion is we need to write the most significant bit as first. The most significant bit will be the bit which is present on the absolute left hand side. In this scenario, it will be our bit 0. Okay. So at first we will write this bit 0, and after that we will XOR get the adjacent bits. So we will XOR 0 and 0, and the resultant bit will be written beside 0. So we have written the most significant bit 0 here, and we will XOR 0 XOR 0, which will be equivalent to 0. So the gray code for 0 0 will be 0 0. Now for 0 1 we will write the MSB which is 0, and now we will XOR 0 and 1, which will be equivalent to 1. So our gray code will be 0 1 for 0 1 binary code, and for 1 0 the MSB is 1, and if we XOR get 1 and 0, it will give us 1. So for binary 1 0 we will get gray code of 1 1. And now for 1 1, if we write the most significant bit as first, we will get 1, and if we XOR get the adjacent bits, we will get 0. Okay, so these are the four gray codes. Okay, so we will represent in sequential manner. So in binary, as we have written 0 0 0 1 1 0 1 1, so for gray code 2 we will be writing 0 0 0 1 1 1 and 1 0, because these are the gray codes we are obtained from 0 0 0 1 1 0 1 1, right? So we will write here 0 0, next 0 1, next 1 1, next 1 0. Similarly for this row also, for the rows also, we have written the binary gray codes for the columns, and for the rows also we will be writing 0 0 0 1 1 1 1 0. Okay, so now we need to mark the cell numbers. So this cell will have a row value of 0 0 and a column value of 0 0. So if we combine those two, we will be getting 0 0 0 0, which will be give us the value of 0. And for the next cell, it will have a row value of 0 0 and a column value of 0 1, which will give us a cell value of 1. For the next row, 0 0 and 1 1. Okay, row value is 0 1, column value is 1 1. So the combined value will be 0 0 1 1, which will give us a value of 3. And now for the next 0 0 row value, 1 0 column value, it will give us 2. Similarly, for this case, we will get 4. Here we will get 5. Here we will get 7, and here we will get 6. And for this case, we will get 8. Here we will get 9. Here we will get 11, and here we will get 10. Similarly, for this side, we will get 12 here. We will get 13 here. We will get 15 here, and we will get 14 here. So these are the cell numbers, right? And now we need to look at our minterms. The minterms are 0, 1, 5, 9, 13, 14, and 15. So the minterms which are mentioned in the questions are particularly the cell numbers in the K map. So the minterms which are given here are 0, 1, 5, 9, 13, 14, 15. We need to look which cell numbers they are corresponding to in the K map. So here this is the cell number 0, this is the cell number 1, this is the cell number 5, this is the cell number 9, this is the cell number 13, and this is the cell number 14. So for the minterms which are mentioned here, we will write the bit 1 in the corresponding cell number in the K map. Okay, so the minterms are 0, 1, 5, 9, 13, 14, 15. So we will write one bit in the 0, 1, 5, 9, 13, 14, and 15, right? So here we will write 1, 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 here we will write 1. 0, 1, 5, 9, 13, 14, 15. Okay. Now the don't care terms are 3, 4, 7, 10, 11. Now we represent don't care by this, either cross or either D. Okay. So similarly, as we have written 1 for the mean terms, which are corresponding to the particular cell number in the K map. Similarly, we will write cross or D for the don't care terms which are corresponding to the cell number in the K map. So for 3 we will write a cross, for 4 we will write a cross, for 7 we will write a cross, for 10 we will write a cross, and for 11 we will write a cross. Now our objective will be to make a group of size 2 to the power n, where n is not equal to any negative integer. Okay, n is not equal to any negative integer. It can assume any value of 0, 1, 2 in this case. So the value of 2 to the power n will be either 1 or 2 or 4 or 16 likewise. So we will make group of size 2 to the power n, and we will make groups with the bits 1. Okay, we can also include the don't care terms if it increases the group size. Like for example, if we write 1 1 side, if we write bit 1 and 1 side by side, and below this 1 and 1 there are don't care terms cross and cross. Okay, so we can make a combination of 1 and 1. It will make us a group of 2, which is allowed in our rule, because we have to make group of size 2 to the power n. So this is allowed. But if we take group of 1 1 and also include this don't care terms here, so this will make a group of 4. So this is also allowed. So our most favorable condition will be to make a group of size which is as large as possible. So if we are seeing a group of 4 is possible, so we will ignore the group of 2. Okay, so here in this case we will follow this rule, and we have to make sure that all the ones are making some group. Okay, like we have to make sure this one, this one, this one, this one, this one, and this one, all of these ones are coming under a group. And if they are not forming a group, for example there is a single one, so we will have to write the boolean expression for the single one also. And by boolean expression I am meaning, if we are forming a particular group, we will write to we will have to write the boolean expression for the particular group. And if we are not forming a group, then we can't ignore a single one. If it doesn't form a group, we will also need to write the boolean expression for this one also. Okay, so here in this case we will see if we can make groups of 1 in the size of 2 to the power n, and we will also see if we can increase the size of group by including the don't care terms. Okay, so here in this case, as we can see, this is 1 and this 3 are don't care terms. Okay, so if we form this group here, if we form this group, this is a group of 4 because there are 3 don't care terms and there is 1. Okay, so this is a group, uh, this is a group of 4 which is allowed, right? So this is a group of 4 which is allowed in our scenario. Now the next thing is we need to look for the other ones. Okay, we need to look whether the other ones can be included in some group or not. So here this is a 1, this is also a 1, this is also a 1, and uh, this is a 1, this is a 1, this is a 1, this is a 1. I have missed one bit here. This is 1 because the minterm 5 was included here, so we will add 1 here. Okay, so we have so far made one group of size 4. We can see here a group can be made of size 4 by including 3 ones and this don't care term. Okay, so this is another group of size 4, this is another group, and the ones which are left out are this one and this one, right? So we need to see that if we can make a group of size 2 to the power n from this. Okay, so at first let write the boolean expression for the groups which we have found until now. So for this group we need to see the value of rows and the value of column. So for this group has a column value of 1 1. Okay, it has a column value of 1 1, but the thing is the row value is continuously changing in this group, right? The row value is continuously changing, right? So we can't write any boolean expression including the variables which are representing the row value because the row values are continuously changing for this group. Only the column values are fixed, right? The column values are fixed at 1 and 1. Okay, so the column values are fixed. So this group is represented by rs because 1 is signifying the variables r and s. So for this group it is represented by variable rs. For this group we can see the value of q is only changing from 0 to 1 but the value of p is fixed at 0. Okay, and similarly in this case the value of r is fixed as 0 but the value of s is changing from 0 to 1, right? So here in this scenario we will, for this group we will write it as uh, p bar and r bar. Okay, because the value of q is changing we can't include the term q in our boolean expression, and here in this case the value of s is also changing so we can't include the value s in our boolean expression. So we will only include those terms whose values are fixed. So in this case it will be p and r, it will be p bar and r bar. Okay, so so far we are getting this two values p bar and r bar, right? So now for the next scenario. Okay, now for the next scenario we will have to make uh, another group which will be here in this case. Let us see if the groups are made correct. R and S. Okay, R and S. Oh, here we can see that instead of making this group we can also take this group, right? We can also take this group because if we take this group is only covering 4 bits, but if we take this larger group it will give us total of 1 2 3 4 5 6 7 8. Okay, total of uh, uh, gr- a group of 8 bits. Okay, so we can also represent this group as a boolean expression because as I have said the group should be a size of 2 to the power n. If n is equal to 3 the size of group will be 2 to the power 3 which is equal to 8. Okay, so we can also represent this group by a boolean expression. So I think this group is particularly not needed in our scenario, so we will discard this group rs. So we will not write this group, we are just writing this group. This is a group of 8. So for this group the value of p or q are continuously changing so we will discard those values, and in this scenario the value of s is fixed as 1 and the value of r is changing from 0 to 1. So we will discard the value whose value is changing. So r value is changing so we will discard it, only s value is fixed at 1 so we will write it as S. And we now need to see if all of the binary ones are covered. Okay, so this one, this one, this one, this one, this one, and this one are all covered. The one which is only left out is this. So we need to see if we can make any group with this one. So we can see, if we take this group, we can also make a group of size 4. Okay, so we need to write the boolean expression for this group. This group will have a boolean expression of the value of p is fixed at 1. Okay, value of p is fixed at 1, value of q is changing, so we will discard the value of q, and in this case the value of r is fixed at 1, value of s is changing. Okay, so we will write it as p and r. So our a boolean expression from the k map will be p bar r bar plus s plus pr. It will be our final boolean expression. And if we want to express the boolean expression by logic gate, we will just need to do the following steps. We will add the inputs here. This is the p, r and s. These are all the inputs. Our first expression will be p bar and r bar. So let us first generate p bar. So when p is passed through inverter and r is passed through inverter, it will give us p bar and r bar, and then we will just pass it through a AND gate to get us p bar and r bar. And in order to get s, we will just write s, and to get p and r, you will just pass p and r through a AND gate. It will give us pr and it will give us s. And if we pass this three inputs through a 3 input OR gate, we will get p bar r bar plus s plus pr. Okay, so this will be our logic gate expression, and this is our final boolean expression. Thank you.